let's understand what is the agenda for this particular session. In this one, first we are going to talk about the linear regression, the basics of that, and then how does it exactly works. We'll also see the maths and theory behind it as well. We'll also see the gradient descent approach that we have taken, and multiplication. Multiple linear regression. How can we do the model evaluation and feature engineering, and like the simple linear regression and the application of the linear regression and the best practices for this one. So this is what we are going to. First of all, we are going to see the the introduction to linear regression, simple linear regression. Then we are going to see the multiple linear regression, model evaluation, and diagnostic, and then feature engineering that we can apply on that, and then at the end application of the linear regression. So this is going to be the agenda, and there is no more PPTs and all this. I'll just be taking the interactive session in this one. I'll be making sure that you guys understand everything, and just make sure to ask the questions when you feel stuck somewhere. If you see that you do not understand anything, you just can ask the questions. I will start this one from the very scratch as much as I can, and I cannot go to the very very basic, because we do not have a time. We have a limited time of 1 hour, and we have to finish this in this particular time frame itself. And as I said, as Mayank also told about this, that if you have to complete this in a given time, in a given time frame, then you should have a particular basic knowledge. If you do not have a particular basic knowledge, then we are actually having one of our expert session, the master class that we are going to have in a couple of months, maybe in one month. So that is going to be based on for this data science and machine learning itself. So basically that is going to be a full-fledged data science, right? We are covering everything from the basics. So the person who does not know a lot about the coding and all that is a basic, even does not know anything about that, but he has a patience to learn about that. So we have launched a course, this master class, which will help him to build a basic knowledge of not only just the coding, but also the maths and statistics behind that, so that when we start machine learning and data science and all the different stuffs in there, so that you can able to understand that. And we'll also be involving the SQL and chat GPT, the hot topics today as well, so that it becomes really understandable and doable. Okay, so this is the agenda for this particular session. For the masterclass that we are going to have. If you feel like you're having or lacking the technological ability to understand this particular topic, that means that your basics are not covered, basics are not good. So what you can do is, instantaneously you can ask me the question. I'll be happy to answer your questions. And not only that, you can also sign up for our the masterclass that we are going to have in a couple of months. So with that note, let's start. So again, this is not I'm going to share the whole time. Let me share a different screen. So where we'll be talking about the linear regression, particularly what exactly is linear regression in theory first, right? So let's see what exactly is linear regression. And if you have any question in between, feel free to unmute yourself if you are able to. Otherwise, you can write us in the chat section as well. I'll be happy to answer your questions over there. So let's understand what exactly is linear regression when I talk about linear regression, right? So it's not any big, clumsy word like when I say linear regression. It's just a creation of a line, right? Why do I want to create a line, and how do I want to create a line, and when do we do create a line? So that's all we are going to see over here. So for example, we have a particular task. Let's say I have a data, right? I have a data of someone's experience and their salaries, right? Let's say I have data of experience and salary, right? So someone having 4 hours experience and they are having 50,000 salary, right? Right. So this is the data. Similarly, we have bunch of data, right? We have, let's say 20, 30, or even 100,000 data sets, right? 1,000 data sets, or 10,000, 20,000, 1 lakh data sets we have for the people that we are in India, right? Their experience and their corresponding salary according to that, right? So what we'll do, we'll simply plot that, right? Let's say on one axis we have a experience, and on the other axis we have a salary. It's a simple geometry. And if I simply plot them, you can see as the experience increases, I'm just having some random data points, as the experience increases, you can see the salary also increases on an average, right? The salary also increases on an average. So let's say this is something, a data point that we have, right? Now, this is a simple understanding of the experience and salary. Now, why would I do to create a line? So basically, in order to basically see the trend, right? In order to see the trend, how by increasing the experience, my salary is increased, at what rate it is increasing at the most, most of it, we just want to see at what rate my salary increases as my experience increases, right? So let's say we wish to create a line. Now, linear regression is nothing but just simple creation of a line that actually goes through this particular data points. Okay. So let's say if I have to create a line over here. Sorry, this is a thick line. So I just want to create a line that passes through, these data points. That's it. Let's say this is the line, right? Now my way to create a line is I just saw the trend and I just draw the line. Mathematically, how can I create a line like this, right? So that is what we are going to see, and that is here called, nothing but the linear regression per se. The task of linear regression is nothing but finding out a line that follow the trend in the data. It's as simple as that. And this is, since we have taken just a single variable here, this is called simple linear regression, and it has only one particular feature in here. Okay. And as I said, if you have any other question, any question regarding this, you can simply ask me. Now, the question comes, are there any other problem other than this? Yes, definitely. There are some other problems that you can solve with this one. Not only this, but you can solve so many different types of problem with the linear regression. As you can see, this is just simple experience and salary, right? We can add some more variables, but that thing that we are going to see in the later on. Now, how many of you knows? Not just I'm just asking quick questions. How many of you know what is the equation of a line? You might have gone through this in your high school maybe, or even before. Equation of a line. Alekia says y is equals to mx plus c. That is a good answer. Where m is the slope of the line, c is the cut on the y-axis, right? So this is what we can also call it ax is equals to bx, y is equals to ax plus b, right? Like that. So let's take a standard equation, y is equals to mx plus c, and if I just change this variable, we can also call it y hat is equals to w1x plus w0. This is what we write in terms of machine learning. This equation we take. Now here, what is y? Y hat is the predicted variable. W1 is W1 and W0. These two are weights. X is input. That's it, right? So this is the bifurcation in our machine learning that we use. These are the particular parameters that we particularly use in the machine learning, right? So this is once we have a salary and then we have a experience. So we can say here this predicted variable will be the salary. Now you might be thinking, why are we doing this? Why do someone want to create a line over this, right? And this input will be experience. So if somebody gives me an experience, I should be able to predict their salary. This is the work that I want to do, and that's why I want to create a line over here, right? A line passing through all the points or most of the points or maybe closer to these points is the best line that I have. Let's say if I'm creating any other line, let's say like this. So tell me which line is better, either line 1 or line 2. Which line is better in this case? So Alekia, again, same answer. Soumya has also given an answer for the y is equals to mx plus c. That's great. Alekia, again, line 2 is better in this case. And again, line 2 is better because it is passing through most of the points that we have, right? It is passing through most of the points. And again, I'm saying participate in this questionnaire, right? So whatever you are understanding, just tell me. There is no one to judge you here. if you are getting something wrong, then your understandability will improve, right? You will understand why I was thinking wrong and why the other answer is correct, right? So just participate in this conversation, right? Even if you are wrong, do not be do not feel that anyone is judging you. Just feel free to answer your give your opinion over here on these questions, right? Now when I create a lines, so for example, if I say that this line and this line, so you definitely can say. Now if I create another line, let's say I'm just creating another line. Let's say this is line 3 now. Tell me now which line is better. Remember which one is line 2 and line 3. So this is, I'll just write this is line 2 and this is line 3. Now here is a problem. Actually, you cannot actually tell that which line is better because they are just slightly up and down, slightly twisted. So it is very, very hard to tell which line is better in this case. So that is here we use mathematical method to find out which line is better. Okay, now how do we use it? So for example, again, I am telling you that why am I doing this exercise? Because I just want to predict a salary for someone who do not know their salary. Let's say somebody is going to join some a job, and they have a particular experience and they want to know their probable salary, what salary they should ask for, right, to the employer, from the employer, right? Let's say if they have a particular salary, let's say 3 years of experience, how much salary they should ask for. So based on our model, this much of salary they should ask for, right? So it's just a single feature. We have just experience. You might be thinking that there are some other factors as well, in which company they are working, what is their role they are working at, what is their education level, what is their age. So all of these factors will play. That is what we are going to see in the next term. And that's when you'll see why do we use linear regression and why do we use multiple linear regression on that, and which one will perform better in that case, right? That's what we are going to see. But the question here, why we are doing this exercise is that because I just want to know the salary of someone having 3 years of experience or a random, let's say 2.5 years of experience. I just want to know their salary. Like somebody who is having that much of experience, they want to know their salary so that when they go to the interviewers, they can ask for a correct salary that they can, negotiate up and down a little bit, right? And these are the true salaries. So my model, that I want to create, I just want to be closer to the actual salary, as much as close it can be, right? I know that I cannot be accurate for all the salaries, but I just want to be most of them. I just want to be close to most of them. That's what I want. And what is that called? The deviation from the actual salaries are called error. So for example, this is my model, right? Let me just erase one line so that I can tell you, how we are doing this. All right. So let's say this is just one line that we have. Let's say somebody having 2.5 years of experience. This is the actual data, right? And they had this particular salary. Let's say this is a particular number, right? Let's say 24,000, right? Now, according to my model, somebody having this much of year of experience, according to my model, he will get this much salary. How much? 25,000, right? So you see the difference of 1,000 from the actual to the predicted. This is predicted, right? This value that is on the line, that is predicted value, because I got it based on my data, based on my model that I have built, right? How I will build my model, that I'll go into further. But now this is just to know that this is the predicted value that I wanted. Okay. So now this difference is called error. Now somebody has actually 24,000 salary, but my model is predicting 25,000. It might be correct. Somebody get different salaries, but just to tell you that since we are doing this regression task, I mean, most of the time, my objective is to be as much as close to the actual salaries. Okay. So that's what I want. Now, this difference between actual salary and the predicted salary is called error. Now, this error can be of so many types. Let's say if the actual salary is higher, right? So let's say if you have simply said that y is equals to error is equals to y hat minus y. Sorry, y hat minus y, where y hat is nothing but the predicted and this is actual, right? Y hat is predicted and this is actual. Now what will happen? Y hat is predicted and this is actual. So let's say if y hat is greater in this case, right? Y hat is greater, which is 25,000 minus 24,000. So what will you get? You'll get 1,000 as an error, right? What happens if somebody says, for example, this particular data point, right? This particular data point, if you see, the actual salary is above the line. The data point is above the line. So if you see this difference, let's say 3,000, whatever difference is, this will come into negative, right? When you use this formula, this will come into negative. Y is equals to y hat minus y. When you use this formula, let's say this is 28,000 and 24,000 is the salary predicted by my model. So what will happen if you just take the negative value, subtract them, then you will get 4,000 as a error. This 4,000 and that too in negative. Remember, sorry. So what we are doing? We are doing y hat minus y prime, right? So we are simply doing 24,000 minus 28,000. So we'll get minus 4,000 as an error. Now, remember, no matter whether we are predicting high salary or we are predicting the lower salary, we will have the same amount of error, right? No matter whether we are, predicting higher salary or lower salary, we'll be doing the same mistake, we'll be doing the same error, right? So the negative value that we are getting, that is not good. Sometimes we are getting positive error, sometimes we are getting negative error. So they will cancel out each other, right? And if the number of points here and there are exactly the same, then that does not make sense. This formula does not make sense, right? If you just add up for all the errors, if you just add up for all the errors in this line, in this data points, for all the data points, right? Maybe we can just cancel out each other. These error may cancel out each other. That does not make sense. Maybe the end result, end error is 0, right? That means I have got a perfect model. When I say end result or end error is 0, that means my line is passing through all the data points, which is not possible in this case, right? So that is why I propose another error. So can anyone tell me another formula which can give me the actual error, not this cancelling out each other's? Do you have anything in mind? How can we, get rid of this negative mark? When it is positive, it should be positive, but when it is negative, it should be positive as well. Because I just want to see the error in whether it is less or more. Its error is error, no matter whether it is positive or negative. So how can you actually do that? Any formula for that? Whatever you can think, any function. Add modulus. Yeah, that's correct. Right? Anything else that you can answer, that you can think of other than modulus? Just think about it. Even we are good to, if the magnitude of the error increases, that's also fine, but we can get rid of this, error. All right. So let's see. Let's rewind back. So we are just understanding the linear regression, and we are going to see how does why do we do the linear regression, and how just how do we create a line over there? Let's say we have experience data and the salary data. We have this scatter plot, and on that scatter plot, I just want to create a line that passes through most of the data points. Now, to create a line, I'm just trying to find out when when the line misses the data points, then in that case, how do we calculate the error? And no matter whether the point is up, above, or the point is below, our error should be exactly the same. So one answer that I have got, that formula should be modulo. So let's add y hat minus y, and no matter whether I write y hat minus y or y minus y hat, it's exactly the same, right? So this is one of the formula. The other formula that we can use to reduce or get rid of the negative option is that they just square it, y minus y hat and the square, right? So I'll just tell you, these are the two different types of errors. This is called absolute error. This is called squared error. Now this is all the summation of all the data points. Remember, this is summation of all the data points. Now just I is equals to 0 to n, right? Similarly, I is equals to 0 to n, yi, y hat I. No matter whether you write y hat and y first or later, it's just since the that does not make sense, the sign does not make sense, so you can write it anywhere, right? So this is the squared error formula, right? This is the absolute error formula. Now for the same formula, we can also have mean absolute error as well. Mean absolute means when we take the mean of it, we just can divide the same thing, this whole formula, by 1 by n, the number of data points, we'll get the mean absolute error. Similarly, we can also get the mean squared error as well. Again, we just divide this whole thing by the mean, we'll get the mean absolute error, right? Mean squared error as well. Similarly, I can also have the root mean squared error as well. If you just take a root of it, right? So we are just trying to find what is the error per point, right? So this particular formula will be closest one. This particular one, the mean absolute error will give me the mean error per point. What is the mean error per point? How much one point is deviating on an average from the line, right? Either above or the below, no matter what, right? So this is what I wanted to find. Now, you see, I have squared this value, whether I'm taking the mean. So this is the square of 1 point. So if I take the root of it, it will come into its normal range. Now I just put everything here. So this will become root mean squared error. Okay, this will become root mean squared error, and these are the four types of basic formulas, 5 types of basic formulas for calculating the error. We also call it error, we also call it loss, we also call it cost, right? All of these are nothing but the simple names for all this, right? So this is what we call error, and we want to reduce this error anyhow. Right. So this is nothing but the linear regression in a nutshell. And how do we actually go with it till here? How do we create a line like this that passes through most of the data points? Let's see as well. So let's see, how do we actually create a data point? Create a line that passes through most of the data points. So in order to do that, again, I'm going to just simply draw the same data here, experience, salary, and let me just draw some data points here. All right, let's say this is the data. Let's say now if I want to create a line over here, so what I will do is I will randomly take a line. Let's say I can take any line. Let's say I took just this line. I will randomly take a line. Let's say randomly I took this line. I could also have taken this, any line I could have taken, right? Let's say I took this line, right? Now I have to bring this line back to here at its original place where it should be, like this. Okay. So how do I do this? So that's what I'm trying to tell you. This is having a gradient descent process within. Let's understand the gradient descent process. What will we do? First of all, we have an equation y hat is equals to mx plus c, right? And then we are going to simply see, we are going to simply predict the value of m and c. Okay, we are going to predict the value of m and c so that we can actually find out the values of these, right? So randomly we'll be predicting the values of m and c, and then we will end up random a line, right? So let's say, so remember the np.random.rand will give you random values in the range of 0 to 1. So first of all, let's say mx plus c, I'm going to write it as w1x plus w0, right? So first process in the gradient descent is randomly predict w1 not predict, randomly generate. W1 and W0. In the range of 0 and 1. When you create in the range of 0 and 1, you just actually limit this line. This line cannot be flipped like this. It will be only, just like this thing. Okay. And most of the time when we create, random values, we actually do this, we follow this convention. It is safe to use actually, right? Now that we have got a random, weights, right? We will end up getting a line, right? We will end up y is equals to W1x plus W0. We will end up getting a line, right? Now that we have got a line, we have got a y hat. Then the second thing is to calculate the loss. I'll tell you, basically we are calculating the loss here in the math, but in the code you can skip this step and directly calculate the partial derivative without losses, right? I'll tell you, it's just derivation. That's why we are calculating the loss here, right? All right. So calculate the loss. When we are calculating this loss, so what we can do is, again, loss, I told you about the loss, right? We just talked about few losses here, right? Loss or cost or the error, both are, everything are the same, right? So absolute error you can talk about. You can talk about the squared error. You can talk about the mean absolute error, mean squared error, or anything. Just let's say I'm talking about the squared error here, right? Y minus y hat or y hat minus y square, right? Let's say calculated the loss, right? Now that I have calculated the loss, the next step here would be to calculate the delta W. Now this process might seem a little bit, clumsy to you guys. We'll be calculating the delta W0 and delta W1 as well. Calculate delta W. Now we'll be calculating for delta W1 and W2 as well. So for calculation of delta W1, we'll be calculating partial derivative of loss with respect to del of W1, right? Partial derivative of loss with respect to del of W1 for delta W1. For delta W0, same thing divided by del of W0, right? So here, the next process that we are going to do, here we are actually going to simply see this, just put the loss value here, y hat minus y, square it up, t of, W1, right? And same thing here. Eventually you will get a particular value here, right? Something, I'm not exactly sure what you will get. I'm not gonna just go and expand all of this and teach you guys the partial derivative. But you can something, I think, minus 2x y minus y hat. This is what you will get. And over here as well, you will get minus 2 y minus y hat. Here you will not get x term because W0 that you are taking, make the other one as a constant, right? W1x makes a constant, and that's why you will not get x over here. So this is what you will get at the end. Obviously, you will not get this y hat. In place of y hat, you will be getting W1x plus W0. If you just make it, so this is what you will get, right? At the end, this is what you will get after doing the partial derivative. Now that you have calculated the delta W, the fourth step is to update the weight. Right? Fourth step is to update the weight. How do we update the weight? Remember, randomly, once you have done the random weight generation, this particular process we are going to do iteratively, right? Iteratively means multiple times, the same process. I'm going to repeat the same process multiple times, as many times as I can, right? So here I'm simply updating this, calculating the loss, calculating the delta W and updating the weight. Now, how do we update the weight? So W is equals to W minus eta delta W, right? If it is W1, then it will be for W1. If it is for W0, it will be W0. Now, one other term that I have calculated here is eta. Remember, we just calculated delta W1 and W0 here. We're just putting it here. And this is nothing but the this is the new W, this is the old W. Remember, I told you that this is what we'll be doing in iterations multiple times. So the previous iteration W will come here, the new iteration W will come here. I mean, you can just simply write it in the code and we'll do this task. Now, what is eta? Eta is another parameter, a very interesting parameter actually, that you can learn about this in the life as well. This is called learning rate. Now, you might be seeing someone saying that, der hai durust hai, or, slowly but steady, like that. So what does it mean actually? So it means that when you learn slowly, you will be learning or memorizing it for a long time, right? But when you learn fast, maybe you can cross the limit, right? So let's see what does make sense over here. What does it make? So what we are doing here, we are actually optimizing the values of W. We are trying to find out what value of W will give me the lowest error, right? We are just trying to calculate the error, loss every time. So what value of W will give me the least amount of loss? That's what we are trying to find out. Now, in that process, we have this eta, right? When we are making the weight updates in this, remember this W, delta W is a very good thing. The sign of delta W will actually tell whether to increase or decrease the weight in the next iteration. I'll tell you why. How. So let's say I'm just taking, single dimension. Let's say just one W. Okay. Let's say just a single W. Let's say this is error or loss you can think of, right? And this is W. Okay. Here. Now, you see, this is the W where the error is the least. This is the error curve. Now, if I have another other dimension for W0, this curve will look like as a blanket, a plane, something like that. Okay. So now my methodology is, so when I told you that randomly I will generate the weight, so maybe I will generate the weight somewhere here, or I may generate the weight somewhere here or anywhere. It's very unlikely to generate the weight in this range. Okay. It is very unlikely to generate the weight at the exactly what we wanted. And that too for two of the variables. Okay. So that's very unlikely. If we could randomly 1 in a trillion times, that will be a miracle, right? Where in that case, we do not have to just do the linear regression process. But if we have to come to this every time, to this value every time, we'll have to follow this particular process that I'm going to tell you. So let's say you randomly generated the weight over here. Currently, your weight is this much. This is the weight and this is the error, right? Now, to reduce the error, what we'll have to do? Do I have to increase the weight or decrease the weight? This particular weight, do I have to increase or decrease it to reduce the error? Anyone in the chat? Nope. It's a very simple thing, guys. So if you see, if you do the change in this direction, as the weight increases, let's say the weight came over here. Now, what will be the new error? The error will be this much. Now, error had been reduced, right? And you have to go till here. If you just go away from here as well, the error will keep increasing again. If you are here, the error is how much? This much again, right? So again, we have got a increasing error. So we have to come here and stop. Now, what are the ways to come here? Remember, when I am making this delta W is the change. The sign will do the task. Like if the sign of delta W is negative, right? So negative plus, and the weight is going to increase. When the sign of delta W is positive, then the weight is going to decrease. I mean, that depends on whether W is here. If the W is here, the sign of the delta W will be negative. Will be positive. And if the W is here this side, then the sign of delta W will be the sign of the delta W that we are doing here, calculating this partial derivative, right? That's a very, very important process in the whole gradient descent. Okay, now why this eta that we have chosen? Randomly, we actually take eta very, very less value. Let's say like this, or 0.0 or 0.1, like that. We do not take a large value of eta. The main reason is behind that is if we have a large error, right? Since we are taking the derivative of the loss, if we have a large error, we will end up getting a large delta W. Once we have got the large delta W and we do not have the eta, right? What will happen? Next iteration, the weight is going to be updated very, very fast, right? Let's say from here, it just came and went here. It did not came here, it just went here, right? It just updated very, very fast. That is why we have a small value of eta, right? So that it will just factor it out. You know, it will factor it out, and whatever value of eta that we are having, you know, it is going to reduce the value of delta W so that in the next iteration, the weight changes very, very less. Now, if we do not have eta, what will happen? Or if we have a larger eta, what will happen? The change are going to be very, very large. So from here to here, and maybe the next time it will go even larger that you cannot imagine. You know, it will just keep increasing. I will show you this process. This particular process is called exploding gradient. Okay, this particular process is called exploding gradient. Now, since this process is exploding gradient, you know, what we can do in this is simple. If you reduce the value of eta, you know, then it will make a slow direction, slow change, right? And in the right direction. So for example, if you have a very, very small change, then it will from here to here, from here to here, from here to here, like that. It will keep coming very, very slowly and then eventually end up over here, right? Now, there are two ways to stop over here. First one, we run our algorithm, this whole process till a fixed, you know, epoch. Epoch is nothing but how many times we are running this whole algorithm. We run this algorithm till a fixed epoch, or we can run a condition, right? We can write a condition. Let's say if the error reduces this much, then I will stop, right? Let's say we have an error tolerance, right? Let's say I say that if the error is less than 0.05, then I will stop, right? But how do I know that 0.05 is the ideal error that I wanted? Maybe my algorithm will never reach and it will keep running. Okay. So just to make sure, we usually run it fixed amount of time, and when you run it couple of times, you know, you will know that, you know, what to change. I mean, change the epoch every time, right? 1,000 times, 100 times, just try to change it, right? Once you do the same exercise multiple times, you will be able to understand that how to change them, you know, what exact value you should put. So this is nothing but in a nutshell, this is what called, and this is how the implementation of linear regression happens, right? If you have any confusion in the code, you can simply ask me. And if you just want to know about this part, how do we came up to this particular solution, you can simply learn about the partial derivative, how to calculate partial derivative. Any question regarding this linear regression from anyone? And remember, this is one of the process that we have followed. This is called gradient descent process. There are some other methods as well. You can also use Newton-Raphson method. You can also use, you know, any of the parameter optimization technique you can use. There are some other techniques. There is also something called least square method as well. There is also least square method as well. You can also use that. So people are saying no questions till now. So let's move to the next topic, where we are going to see actually the coding implementation of this. Right? Let's see how can we implement the code behind it. Right. So let me just open my code for it. I'm gonna let me just open the code. So the regular batch that I teach, I have implemented this course since we do not have a lot of time left. So I'll just quickly move you around through the code and I will show you. And remember, as every iteration wise, as the error decreases, you will see the line changing from this original position to the correct position that we have, right? This is what we are trying to actually achieve. So let's see what exactly is linear regression. So here I have simply, created some data points here. Now you can see these are some random data points that I have taken. This is the line. Obviously, they are not in linear trend, but they are having a very good trend in them, right? Now, first process that we are doing is randomly generating the weight for this W0 and W1. Now here you can see that these are the weights that is generated, right? Sorry, these are the new weights that is generated. And these are the new prediction based on the current weight, right? So these are the predictions. And when I plot this line, this is the initial line that you can see. If I run it again, since this is not seeded, so you will see a line like this. Every time it will change, right? This time it has this particular value. If I run it again, it will have a different value, right? Now, now we have this eta. I have just defined it. Let me just show you a larger eta. What can a larger eta do? Let's have a 0.1, right? I'm running it 1000 amount of time, 1000 time epoch, and this is an error list to actually take the errors in every iteration, how the error is increasing or decreasing. And this is actually my formula for, partial derivative. So you can see the same thing we are doing. First thing is that we are calculating the loss. Then we are calculating the delta W1 and W0, which is partial derivative. And then we are updating the weight. These are some implementation methodology that I have taken. I'm initializing W0 and W1 with 0, epoch error with 0, and so on. This epoch error is basically calculating the epoch in every iteration, every epoch, and then appending it into this particular list so that at the end we can see that what was the error at the end of every epoch, how the error was decreasing or increasing, whatever. Right. So let's start running it from again here. And let's see what we have got. So remember, what did here? I increased the eta. Value of eta is very, very high in this case. And let's see what is happening in this. So you see, this is the, these were the, sorry, these were the errors in the first iteration. Right? These were the W's in the first iteration, right? Now you see, the W got changed very, very much in just a single iteration. Again, in that iteration, it got changed again more in the other direction. It is negative, in the negative direction. Again, in the positive direction, but even more than the previous. Again, in the negative direction, but more than the previous. And remember, this was the process I was telling you. This is called what? Exploding gradient. My gradient is actually exploding in the both of the direction. Remember, both the direction of the curve. I was talking about this, right? So this is what is happening. Now you can see at the end, it just became infinity, right? E to the 10 to the power 161, and it's a very, very large value. And you can also see how error is increasing. 227, 527, and then this much. So this is a basic, error increasing, right? Due to my large value of eta. What happens if I take a small value of eta? Let's say take a small value of eta. And remember, this is the predicted line. This is the initial line that I have drawn with the help of the random weights that I have generated. Right? Every time, as I told you, I'll run it. It will have a different values every time. All right. So let's see. So let's say again, this is value that we have, and let's run it again. Now that we have increased our value of eta. Let's see what we get. Now you can see it is changing very, very slowly, right? And you can also see the error. Error is decreasing this time. First error is 378 and then 132.49. And at the end of the 100th epoch, we have got this much error, 6.1, right? And here, again, we are predicting based on the current W0 and W1. And if you see, this is the result that we have got. This was the initial line that we had. This was the actual data. You can also see the marker over here. The blue one is the original data. This is the initial line without fitting, and this is the final fitted line based on the linear regression. So this line, the red line, has come into the position of the green line. I mean, these are the same lines, but in two different amount of time. This was the line when initially we had generated the random weights, and this is the line which actually is fitted right now after running the code. So this is, this is the beauty of linear regression. This is what this gradient descent does. Now it will help you to approximate anything, any line that we have, right? Now, one experiment that I want to tell you quickly. Now here I can, let's say, increase the value of epochs so that I want to converge more, or I can just try and increase the value of eta very little, not so much, so that I can see whether it works in this sense or not. Let's see. You can see now it is even better. You can also see the error has been reduced to 3.72. The error has been reduced to this much. Previously it was 6 point something, right? So it's just a matter of fact that you are using a good, till where you can run it, how much time you can give it to this to run, and where you are actually settling with this. So that is it. This is what the linear regression. If you want, I can share you this code to you guys as well, and you can just play and do some experiment with this one. So this is it with for this code. And if you have any question regarding this, you can ask. And so this is what the linear regression does. And since I think I'll just tell you a brief understanding of multiple linear regression as well. And maybe I can arrange the later session in the next webinar, where I will be talking about how can you, this is just, I'm talking about a single feature. Remember, 1x and 1y. What can we do if we have multiple axes? Multiple axes, let's say in this data, we do not have just experience. We also have the age, right? We also have the education, right? Let's say we also have some other factors. I want to include all those factors to calculate the salary. Now this much will be better, or just the previous model which only have the experience, that will be better. Which will be better, having more features or less features? It's a question for you. Okay, Soumya says less feature. Why? I'm not sure why having less feature will help you. I mean, I'm not talking about too many features. Like from 1 to 10, 15 features are allowed. I mean, having more features mean having more information about the people. If you have more information about the people, then you can do more gradient search. For example, just see, if I ask you to predict someone's salary just by knowing their experience, it's not possible. You must know where they are working on. Right? What is their age? Right? What is their education level? If a 10th class guy has a 4-year experience, he will earn very, very less. Right? Versus a PhD guy who has a 4 years experience. His age will be also higher. So these factors will be impacting the salary very, very much. So one feature cannot predict that. Having multiple feature will help you that. And having multiple feature, ladies and gentlemen, called multiple linear regression. And this particular topic, and maybe further, we can also deep dive into polynomial regression as well, right? So this particular topic, maybe I'll take into the next webinar. So that is called multiple linear regression. So that's it. If you have any question regarding this, you can ask, or this is the end of this particular session. Thank you, everyone. Soumya, in that scale of 10 to 15 are good. Yeah, I mean, if my data set is very, very high, then in that case, less features are adorable, and we also have to think about the quality of the feature. You cannot just discard all the features that you have. You just then think about the quality of the features, and also how much computation power that you have, right? So combine everything. You can actually then you can think about reducing the features or increasing the feature. That's it. But if you have just one feature versus 4 feature, definitely 4 feature are more useful in that. So that's, thank you. Thank you again. Thank you, everyone. If you again have any question, then I'm here to help you guys on the same here. So that's great. So any other question from anyone, or I'll just stop sharing my screen. Okay, so thank you. Thank you, Prabhat. Thank you, Soumya. All right, I guess no questions then. So thank you again. Thank you to everyone for joining this webinar. We'll be doing this webinar quite really well. And if you want to just do this, pretty from the basic level, then you can definitely check out our masterclass that we are having in a couple of months in collaboration with IIT Roorkee. More about this, Mayank will explain you about that. So thank you, everyone. Thank you again. I hope seeing you guys in the next webinar. And yeah, that's it from my side. Over to you, man.
Yeah, thank you, Akash. It was really insightful. I hope everyone liked it and it was helpful. So if you guys have any question, you can still ask. Okay. So before we start with any question answer, I will help you go through the IIT Roorkee course which we were talking about. Others, just let me know if you so, can see my screen.
Yeah, sure. Yeah, I can see your
Yeah.
screen. Yeah.
Okay. So once you log into our skill Vertex website, you will see a tab here, noting executive certification program in data science. So once you open it, on that tab, you will see the home screen. So you can download the brochure here by providing the basic information. So this is a certified professional program. You will be taught by industry expert. This particular program is in association with I have Divya Sampark, which is part of IIT Roorkee, and certification will be provided by the I have Divya Sampark and IIT Roorkee. So you will be having 40 hours of live classes with projects and assignments. You will also have the doubt clearing session, placement assistance from our experts, and this is how the certificate looks like. So this will add a value to your resume, and this course will not only help give you just one certificate, it will make you industry ready for your upcoming professional journey. So you can download the brochure and get more information here. So what are the job avenues? This scientist, data engineer, data analyst, and we have many partners with us, and our alumni also work in many of the prestigious MNCs. So you can also showcase your skill and get a chance to work with any of the MNCs. So post this program, you will be skill ready, and you can join any of the MNCs depending on your choice and your skill set. So we will make you ready for your journey, and you can also explore the curriculum here. It is a detailed curriculum one, and here are some capstone projects which you will be doing with this program. Mm. Here are some of the tools which you are going to learn: SQL, Cloud, Python, and many more. So here are some of our alumni which are currently working in the industry post this. So you can just simply go through this, and if you require any assistance, you just submit your details where the counselor will help you. So if you have any questions regarding this course, I'm happy to solve your doubts. Anyone have any doubts? We'll wait for two more minutes. You can also ask regarding any other programs. What about regarding, can you just elaborate a little more? We will be conducting this kind of master sessions every week. We will be conducting master sessions every Friday, Saturday. Every week we will try to conduct these master sessions to give you more insights of how things are in its mind and what to do this role, why this role is in demand correctly. So if you are interested in upskilling and pursuing your career in data science, you can just simply sign up here and download the brochure. And also, you, our counselor will be connecting with you to help you out with how you are going to proceed in the course and what will be the fee structure and everything. So as you are joining the webinar, definitely your fee structure will be different. You will be given discount for you. So any other questions? Okay, guys, so this was a wonderful session from the council. And please also, if you miss something, you can visit our YouTube channel and you can cover it there. We will be conducting this type of master classes often. Please feel free to join and also feel free to your plan. We will also join and learn and know about things in data science. So this was it. Good night, everyone. We hope you enjoyed it. We'll meet again with another session. Thank you, guys.